Okay, so the next question asks now for the ratio. Determine the ratio power dissipated in the LDR over power dissipated in the 240 ohm resistor. Power dissipated in the LDR over power dissipated in the 240 volt resistor. Now, there are two possible ways of doing this. You could need to know the current. You could use the ratio of currents. Power, remember, in the LDR over power in the 240 ohm resistor. You could use the issue of current and say, okay, current squared times resistance, that's for the LDR. Then current squared times resistance, that's for the 240 volt ohm resistor. So that's one way of doing it, because we know both the currents in the LDR and the current in the 240 ohm resistor. We know the resistance of the LDR and the resistance of the 240 volt ohm resistor. That's one way. Or we could do the other way, whereby we know that this is the formula of power. Power is V squared over R. So the power in the LDR divided by the power in the 240 ohm resistor will be the voltage started coming from here, voltage squared over the LDR, across the LDR, divided by the resistance of the LDR, voltage squared across the 240 ohm resistor, divided by the resistance of the 240 ohm resistor. Then, since there's a division sign, when it becomes a multiplication, we invert. When we invert now, 240 is on top, 9 squared is at the bottom. That's the voltage across the 240 ohm resistor. This is the voltage across the LDR, which is also 9. So 9 squared, the 9 squared cancels. 240 divided by 720 gives us 0.33. The intensity of the light incident on the LDR increases. State and explain what happens to the voltmeter reading. So they want you to explain what happens to the voltmeter reading if the intensity of the light that is on the LDR increases. So we want to trace what happens to the voltmeter reading. So ultimately, it's all based on understanding what happens to the voltmeter reading. Now, there are two things about knowing about what happens to the voltmeter reading. This voltmeter reading is based on IR. So ultimately, since the resistance is 320 already, it's a constant, the voltmeter reading is based on the current flowing through this resistor, which is also the current flowing through the battery. But now there's something special about current flowing through the battery. Current flowing through the battery is the voltage or the EMF of the battery divided by the total resistance in the circuit. So we need to know that if the resistance of if the light intensity increases, how does that affect the resistance in the circuit? Because how it affects the resistance in the circuit determines how it affects the current in the circuit. And how it affects the current in the circuit determines how it affects the current in the 320 ohm resistor, and therefore the voltage of the 320 ohm resistor and the voltmeter reading. So we know that the resistance is inversely proportional to light intensity for the LDR. When light intensity increases, the resistance of the LDR decreases. So this resistance is decreasing. So when the resistance decreases, or the resistance of any part of the circuit decreases, whether in series or in parallel, the combined resistance decreases. So when the combined resistance here decreases, then the combined resistance for all of them here decreases also. So the combined resistance of all the resistors in the circuit is decreased because the resistance of the LDR has decreased because the light intensity has increased, which means that the current through the battery, which is the voltage or the EMF of the battery divided by the total resistance. If total resistance has decreased in the circuit, then there is current in the battery has increased. But the current in the battery is also the current through the 320 ohm resistor. So if the current through the 320 ohm resistor has increased, then using this formula for the 320 ohm resistor, current times 320 ohm resistor, if the current has increased, then the voltage across the 320 ohm resistor has also increased. So the voltmeter reading has increased. So I shall read the answer. Resistance of the LDR decreases, of course, because light intensity has increased. This reduces the resistance of the parallel combination, and hence the total resistance of the circuit decreases. Since I is equal to V over R, in this case the V is the voltage of the battery, the EMF of the battery, and R is the circuit resistance, current in the circuit increases, which is also the current in the 320 ohm resistor as well as the which also increases, sorry, I didn't write it correctly, which also increases the current in the 320 ohm resistor and the PD across it, according to what I explained on top there.